Okay, to continue the class, last time we covered the basics of classes, class methods, and objects. Now we'll go into a little bit more detail with a good example. Uh, Today we're going to think about a class that we are creating for an account, and we'll keep it very simple. The account is going to just have three attributes: the account ID or the account number, the name on the account, and the balance. So we'll see how that example plays out, um, and we'll see how to do it. When we start first developing a class, we use the class keyword. Then we give it the class name. We typically use the convention where we use the first letter to be capitalized. Before we even write a class, if you want to just keep a placeholder, we put in a pass command. I think we spoke about it a few classes ago. Say I know that I have to create a class account, and I'm not really sure what methods need to be there, or I need to do that a little later. So I'm just going to put in a placeholder. So say if I do that, I just have to write a class and write a pass statement. So this in itself, now Python will be able to understand that there's a placeholder here, and we're going to create a class called account. And to create an object, I think we saw this last week. All we have to do is, this is the object that we're creating. We call the class name and then use open brackets, close brackets. That would mean that we are instantiating that class, or we are creating an object of the type account class. So we'll see if Python uses this. We'll see what it actually assigns in the memory. So if you look at it at this location, it puts in, for AC1, it actually sets an account object at this memory location. And so that's even though this is just a placeholder, it still creates an account object. Now let's expand upon the account object itself, or the account class. So now we want to say, okay, we want to have an init class, and as we saw earlier, init class is a default class that Python has. Like, even if you don't set it up, this is going to be there. And then within the account class, we're going to set up three variables, and we're going to set up the init class here. And let me go into a little bit detail and explain what the self is. And self is just a convention; it's not a keyword, so you don't have to use self here. Like, you can use ABC or whatever. But what essentially we do is, what we essentially do is, when we call this like AC1 is equal to account of 1, A and 1000, what we essentially are doing is, we're calling this method init method. Even though we're creating a class, we're calling this init method, and we are passing the object itself. So it passes the object, and then it passes all these variables that we list. So here, the first one is ID, second one is name, and the third one is balance. And balance is optional; you don't have to actually specify it because we have a default value. But that's what happens in the background. So here, this first one, we typically name it self, but that's just a convention. You don't have to name it self. You can call it whatever you want. And that would be taken to understand that we are passing the object, and in that object, for that object, we are assigning the ID to be the value we passed. So we're passing 1. So for that object AC1, ID is being set up as 1, and the name is being set up as AA, and the balance is being set as 1000. So if I run this, so now we have added an init method, and we've assigned the values that you're passing to the object itself. So that's something we've done. Now that we've assigned it, say I want to call AC1 and understand what the name is, I'll be able to get it. So I'll be able to actually access the methods there and say I want to get the balance. I can do all that. So after this class is instantiated, I can call the variables inside this, and then I can get all those variables. So that's what I'm doing here. I'll get into a little bit in a little bit, but these are actually object variables because those are assigned to that object, and we are actually modifying, like we are actually accessing them and being able to use them. These are not class variables, that is, these are not defined at this level. So if I say a is equal to I, like 10, so this is a class variable. And this is an object variable. So if you look at that, we are actually, what we're doing here is we are actually accessing the object variables. Last week we saw a concept where we saw something called encapsulation. So let me quickly revise what that is. So encapsulation is a concept where you can restrict the methods, like access to the variables or methods in any programming language. So this way what happens is we don't actually allow the object itself to modify something or kind of use it for something else. So to do that, we actually use something called a private variable or a private method, and then we allow access using that private method. So somebody can actually get methods or set methods to actually modify the variables, but actual variables itself we cannot actually access directly. And to that, in Python the convention is that you use a single underscore or a double underscore as a prefix, and that will tell it, like here, right? So we have a single double underscore there. It tells that this particular variable cannot be accessed from outside. So we have a set method. We also might have a get method. So in this case we have a set method, and we could also probably have a get method to actually update it or get that information. So that concept is called encapsulation. So let's get back to today's coursework. So whatever I've done here is not wrong, but it's not the right convention, and it's not the Pythonic way of doing it, and it's not the OOPS way of doing it. So especially if many other people are going to use your classes, many other people are going to use your methods. So we try to have them as private, and then try to use a get or a set method to actually access it. So let's talk about that. How do you access object variables and how do you modify them? Say now that I have not set it up, say today I want to check something with my balance. I'm outside this method, I am outside this class definition, and now I'm trying to check what the balance is. And if it's greater than 500, then I print it's above minimum balance. I'm able to do that today. And if I want to change the balance, so this balance was earlier $1,000. Now I'm changing it to $1,500 or $1,500, and I'm able to do that now. To be able to restrict that, the way we typically do it is we use private variables. So the way we do it is inside the init, we pass ID, name, and balance, but we set it to the variables called double underscore ID, double underscore name, and double underscore balance. So the double underscore tells Python that these are private variables. Again, Python is not very restrictive, so it doesn't mean you cannot really modify them. There are ways to actually access them and modify them, but at least convention wise, when we use a double underscore, it makes it not able to directly update it. So here, when I set up a so the class, and then I have double underscore here. Now when I call the AC1 and then set up the account to be like ID1, account number 1, and uh, the name is AAA and the balance is 1000. Now when I try to print the name, I get account object does not have an attribute name. What are the attributes it has? To find out what the attributes it has, you use something called double underscore dict double underscore. So that would tell you what are the dictionary values that this particular object AC1 has defined. So if you see AC1, it has account ID, and if you see there's a double underscore ID, and that's stored as 1. So let's do this here. So here, before changing the definition, here I don't have double underscore. Say here I execute this, and after this I try to understand what AC1 dot double underscore dict is going to have. It has it if you see, it has just the 3 values: ID, name, and balance. So when we're not using private variables, all we have is here we just have uh, the the variable names that we defined and then their values in this dictionary. Now after we change this to have private variables, these private variables are not going to be accessible from outside. So this one, you can see that the private variables are not accessible. But they're not, like, compared to other programming languages, Python does not completely restrict you. So you do have a way of accessing it. So if you look at this, if you look at the dict, we know that it's actually stored under this name. For ID, this name for account name, and this name for account balance. So you can use those names here and say you want to print them. I'm sorry, I got to execute this again. So let me execute this, and then let me execute this. Now when I execute this, so what's happening is I have private variables defined here, and then when I actually like print them out, I get the variable name underscore account double underscore name. So this is the name of the class, and then this is the name of the actual class variable that I have. So with that, I'm actually able to access the object variable. But this is not the Pythonic way of doing it. So typically these variables are not accessed this way. So this is not the right way of doing it. This is not a Pythonic way of doing it. This is not uh, uh, the right way to do it. But like, say for whatever reason you want to see what value it has, and you would like to go through that, then this is a way to get through that. Okay, so the next one, let's get to how do I, okay, now I want to encapsulate my ID, my name, my balance. How do I actually allow that encapsulation to happen? How do I allow people to get the balance from outside, so you need to have get methods. So I'm having three methods: get balance, get ID, and get name. So all that does is it returns the balance out. It returns the private variables out, so that you can actually print it out or look at what value it has, and stuff like that. So that's the use of having the get methods. In this case, I've not really built the set methods because I thought probably I don't want to set the account balance unless somebody puts in money or takes out money. So just to explain how these methods work, I've set up get balance, get ID, and get name. So say we set up 4 accounts: AC1, account number 1, AA and 1000, account number 2, BBB and 4000, account number 3, CC and 300, account number 4, DDD and 5000. So say we set this up. Now we have 4 accounts. If I actually print any one of these objects like AC1, so I'm getting that it's an account object at this memory location. And if I want to print AC, say 3, it will be a different memory location, but it has the similar account object. And now if I want to print the ID, I can't use this, or I can't use .id. So none of that would work. So none of that would work. So these two are not accessible from outside the class. So what I would actually need to do is I need to use the get methods that we wrote. And the get methods, all they do is they just return the values out. It's a simple get method. It's like one line. It just a return. So here, when I want to return it, I use the get methods, and then I get the account ID, the balance, the name as well. Now let's get into a bit more functionality that we want to do. So now we have 4 accounts. We have set up their initial balance. Another functionality we would like to do is probably allow users to deposit money and withdraw money. So I'm setting up like 2 methods for that. One is deposit money. Whenever somebody deposits money and they pass in an amount variable, then what will happen is the balance would increase by that amount, and then we'll get a return success. And whenever somebody withdraws money, it will check if the balance is greater than the amount. If it is, then it will change the balance back, and it will return success. If not, it will return insufficient balance. So say I have the same 4 accounts and I set it up with these additional 2 methods. And I'm adding something called a class variable here. And class variable is something that's not inside any of these methods. It's available in the class itself. So those are called class variables. And in addition, what I'm doing is I'm adding a count class variable. Each time an account is created. So this will keep a count of how many accounts are there. So until the program is active, if we keep creating accounts, so at the end, we'll know how many accounts have been created, or at this point, how many accounts are active. So we'll know that by accessing the count variable. And the way to access the count variable is by just calling the class name .count, because it's not an instance level variable, it's actually a class level variable. So the right way to do it is by accessing the class account and then calling the variable count. I mean, Python does allow, so let me do that. Python does allow us to actually call ac1.count, but it's not going to give you the count when ac1 was created. But because this is a class variable, we're going to get 4 all the time. So whether we call ac1.count, ac4.count, you're still going to get the count as 4. Say I'm going to create another account, ac5. So now when I print ac4.count, because the actual count variable, which is actually a class variable, is changed, I should expect that also to be changed as well. So if I look at this ac4.count, ac5.count, or account.count, everything should still be the account level variable, class level variable. So it should still be the same. And given that it was 4 earlier, and then we added one more account, I'm assuming it called the init method again, and the init method added one more, and now we're going to probably have one more than 4, so it's probably going to be 5. So we see that the account.count, ac4.count, ac5.count, everything has the same value, 5. So now let's do this. We had the deposit money and withdraw money methods that we created. Let's try using that. Let's use the ac5 dot deposit money. Let's say I deposit $4,000. At the start it had $8,000. Now if I add 4,000, it's probably going to be 12,000, and it should return a success, I believe. I'm sorry, that's an error which I didn't expect. So AC5 dot deposit money of 4,000, it calls the amount here. It tries to see self dot underscore balance, but there's no way to actually get the balance. So it's going to do so now that we have deposited the money, um, let's try printing the AC5's balance. Get balance would be the method for that. So now that we had 8,000 in the beginning and then 4,000 later, now we have 12,000 in the balance. Now let's withdraw AC5 dot withdraw money, and let's say we withdraw $10,000. And then if I check what the balance would be, so it should have reduced the balance. Now I get back 2,000. Now we want to see if our code works where we can't withdraw less than say now I want to withdraw $10,000 more dollars. It should not allow me because my balance is just $2,000. So it says insufficient balance, and when I check the balance, it should still be $2,000 because the transaction failed. So that's kind of the logic where we use like these methods. So whenever we create a class, we definitely want an init method. We might need to use class variables, and we can use class variables inside these methods, but there are better ways to do it. So let me take that the next concept that we'll cover. But this is a way to do it. So you can actually access the class method by using the class name here, dot variable name. But there are slightly better ways to do it. We set up get methods and set methods so that we can encapsulate the variables, the methods, so that it does not get used from outside. So that's one thing we need to consider. So what are the methods that we need to encapsulate? What are the variables we need to encapsulate so that we can call from outside? What are the ones we allow to do? What are the ones we don't allow to do? Say here we are changing the object values, but when we change them, what should we allow them to do? So here we are allowing somebody to deposit money, somebody to actually withdraw money. So for those cases, somebody can actually call these methods from outside. If you don't want these methods to be called from outside, then you put in a double underscore or a single underscore there, and it becomes a private method. So that cannot be called from outside. You could probably call it from another method. So we can have an authentication method here, and after the account gets authenticated, then that method would in turn call the deposit money. So people cannot, like, say somebody from outside cannot actually deposit money, but they can call an authenticator and deposit method, and that authenticator method, after it authenticates, could probably say, okay, now do the deposit money. So it could call in something that has a private method. So those kind of cases, we'll have to see what are the get methods, the set methods that people have access to. That's another concept. Now let's go into the concept where we use these class level variables. Say now we want to just work with class level variables. We should not use these object methods. So these methods are called object methods because the objects can actually call this. So we can actually say ac1.getName, ac1.getID, ac1.getBalance, ac1.deposit money. So those are object methods, anything that can be accessed by the object. So now we want to have class methods. So let's get there. So the next concept we're going to cover is class methods. So let's also do one thing quickly. So I'll show you the dictionary of the object itself and the dictionary of the class. So the dictionary of any object would have all the object variables in it. So in this case, it's ID, name, and balance. And if we actually call the class and we want to see any like variables that are there in the class variables, those would only be available in here. So we had a class variable called count. So if we see that count variable is actually part of the account, the class dictionary. So the class has a dictionary that has the count variable, but this one, if you see, the AC1 does not have any of the count. So even though this is the case, when we call AC1.count, we actually get the value, and this is because Python does not find this count here. So it goes back and looks in the in the actual class itself and then returns a class value outside. So now that we've created 5 accounts, the value now is 5. All the methods that we created um, and the accounts that are the methods that are default by itself. So we created a method called getID, so it's stored as a function. GetName, it's stored as a function. Deposit money, it's stored as a function. Withdraw money is stored as a function. These are all the methods we created. But Python by default creates a few. Like even if init is not created, if we had not created it, Python would have created an init by itself. Python also created a dict function that shows all the dictionary of all the attributes. It does a weak ref and then it does a doc. And doc is nothing but a doc string. So if we had put in a value here, this class maps to a bank account. So if we do this, we can see that the dictionary would have, so currently if you see the dictionary here, the doc string has none. Now it should actually have something in there. So where did it go? Okay, so yeah, I can see the doc, and the doc one has this class maps to a bank account. So so we can see that created here. Any new method that we create, it will get created in this dict. So we can, to see what the class has and what it stores, we can actually use this. And if you see the difference between the object dictionary and the class dictionary, you could understand that this count is definitely a class level variable, not a object level variable. So now that we understand what a object level variable is in a little bit more detail, let's go into what a class method is. So let's add to the same account class that we had. Let's add 2 more class methods. One is update count and get count. So what we're doing here is there is a class variable count. Here I earlier had a way to update the actual class variable, and I said account.count is equal to account.count plus 1. Now instead of doing that method, instead of doing that particular statement, I'm going to move that into a method called update count, and then I'm going to call that from here. Yeah, you could do that, but I don't want that to be actually a object method. So I'm going to actually call it a class method. So what is a class method? Class method is the first variable that it receives is not a object, it's actually a class. So it actually passes the class itself as the first parameter. You could pass more parameters to this, but if you look at this, so the first method in the implicit arguments is the class itself, and then we can pass other arguments. So here what we're doing is we're calling the update count, and here the same logic that we used to do earlier, here I'm moving it into this class method, and I create another class method to actually get the count. So here I'm doing the same kind of things. I'm adding like 4 accounts. Now when I want to get count, I can actually call the get count method, and that throws the value that I want into that. So that's how we will use the class methods. So the class methods are useful whenever we are actually doing something with the class itself, we're modifying class variables, the whole uh, class has something that is relevant to the class, not the object, then we use the class method. That's one concept we use typically when we do day-to-day programming. So that's good to know. Another thing we use is the static method. So the static method, now we are adding more to the same account class that we had. Now we're adding something called the static method, and say in the static method we're going to define something called account open rules. So somebody is opening an account, it's not particular to account 1 or account 2 or account 3. It is just applicable to all like um, all accounts, and like the variables that are used inside are static variables. It's not, we're not using any class variables, not class.count or anything like that. So we're not modifying any class variables, we're not modifying any object variables, so we're not modifying any of these. So we're not modifying any self dot something, we're not doing any self dot balance, we're not doing any self dot id. So we're not doing either the object variables nor are we doing the class variables. So cases where we don't want to do either the we don't want to manipulate, change, or use the class variables, or manipulate, view, or change the object variables, then we use something called a static method. And here, as you see, the first one is we don't pass the class or the object. We don't pass the class, or we just pass the arguments. So in this case, I'm not having any arguments, but yeah, if you pass arguments, we don't have to say class, comma, argument 1, argument 2. We don't have to say self, comma, argument 1, argument 2. So we just have to, so here if you see, we say self, comma, for all object methods. For all class method, we say class, comma. And for static methods, we directly can have the arguments. So we can have the arguments here. And then here, what I'm going to do is, it's going to return the account open rules. So it's going to say provide the government ID and the minimum balance of 500 or whatever. So it say even if it's a long list of rules, so it can return that. But because it's not modifying any of the object variables, that is any of the self dot stuff, or the class variable, that is cls dot stuff, it can actually, those can be defined as static methods. And static methods, you don't really need to like instantiate something to actually use a static method. You can directly use it as it is. So here, say I don't set up this. Let's try what's happening there. And then so at this point, what I've done is I've stopped everything. I've redefined account, and now I've not even instantiated any one of the class variables. I can still print the get account open rules. Now, when I actually instantiate these variables, and then I get a count, I'm able to print the count of that. But here, if you see, I'm directly using the account variable here. So that's the difference between the static method, the object method, and the class method. So there are three methods that we saw today. Those three are differentiated based on, are we going to use it at the instance level or the object level? So that will mean object method. If it's an instant object variable, then it will be one of the variables within the instance method. It will have the self parameter. If it has a class parameter and it has the class method at the top, it's a class method. For static methods, we have the add static method, and we typically don't use the class methods or class variables or the instance variables in that. So we directly have the arguments inside the method. So now let's talk about inheritance. So we spoke about inheritance last time, and I haven't really provided like we saw an example, but let's extend this example of account and see how we use inheritance in it. So if you look at that, we are doing a class savings account, and then for now we're just having a placeholder. So I'm going to put in the pass command, nothing else. Right now there's no code. All I tell them is I'm creating a class savings account, but it actually inherits the account class for that. So in that case, can I actually use the savings account method here? Even though it has no init, it has nothing else defined here. Okay, so if I create a AC1 save and I say savings account of 101, saver 1 and $20,000, if you see it created it, and I'm able to actually use the methods in it. So I'm able to use the get balance. If you see, this class has no method called get balance. It has inherited the get balance method from the account class, and I'm able to get the balance here. Say if you want to withdraw money, so if you want to say AC1 underscore save, which is actually a savings account class, and within which I want to do withdraw money, and I want to withdraw say $5,000. Okay, I think for now I'm going to make this not private, just to keep it quick for the class. But essentially the right thing to do is to actually have all these as private. But in this, I haven't defined it at private in the init and in other places. That's why it's causing an error. So I'm going to go back there. Back here. And then I'm going to withdraw the money. So we can see that even though our class savings account has nothing in it, but because it inherits account, we're able to use that to withdraw the money. And then we're able to use the get balance. And if we actually use the count, so the count now is 5. That is, even though I have not really called, like if you look at this, I've only called it 4 times. The count was 4 at this point. After this point, I did not call the account. I did not instantiate the account class at all. I'm just instantiating the savings account class. But that adds one more number to the count of account, and now I have 5 as the count. I'll do it one more time so that this kind of is. Say I do a AC2.save, and say it's 102, saver 2, and his balance is say $2,000. Now when I check the count, I expect it to be like 1 more than earlier. So here I'm not calling the account. I'm actually not instantiating the account at all. I'm instantiating the inherited class savings account, and there's one more object created for that. There are 2 objects that are savings account, and there are 4 objects that are account. Now the count is now 6. That's how, I mean, that's one other example of how inheritance works. Now let's add more functionality to the inherited account. So now I want to have the same init, but I want to do something in addition. So how do I do that? I just redefine init here. So if I put in redefine init and then I write whatever code inside it, that will be the new definition. So whenever somebody calls savings account with init, um, so it does the savings accounts uh, logic instead of actually the accounts logic. So it doesn't do the logic in account, it actually does the logic in savings account. So that's one concept we learned last time. So we'll see how it works here. So what I'm doing here is I'm actually calling the super. That is, I'm calling the super here is account because we inherit from account. And the super has an init method. So I'm calling that method. So I'm doing whatever the account did. And then I'm adding some more functionality. Here I'm adding some extra functionality. So what it does is essentially it calls the account init and then it does some extra functionality and it assigns interest rate. So the interest rate is going to be, if the balance is greater than 3000, it assigns interest rate as 2, and if it's less or equal to 3000, so it's going to set the interest rate as 1. So no logic to the interest rates, but just to showcase that we are able to change the init method itself. So now we are able to change the init method, and then so if I actually call let me recreate the account savings AC1 savings, and let me call the get balance. So it calls the get balance method. I'm able to get the $20,000 balance. Now if I want to check the interest rate, because it's a savings account class, it actually has another value called interest rate, and it's because it's greater than 3000. Now the interest rate is going to be 1, the 2, sorry, it's going to be 2. If I want to see what is on the dictionary of account save, I can see that now it has 4 variables. Earlier we saw that AC1 had only 3 variables. So the ID, the name, the balance are similar. The interest rate is in addition. So the inherited one can have more. Even if you redefine this, and you can actually have less, that's possible too. Completely redefine this, like with less. You don't want a name here, remove that. You could redefine it. You cannot use the super here, and then you could redefine all those things here. So you can do whatever you want inside this. You can have lesser variables, more variables, do whatever you want. You can redefine the init. You could also add more methods. Say I want to add in a savings account, I want to have more functionality. I can add, so I want to use like deposit money, withdraw money, but I also want to have calculate interest rates, or I mean interest amounts. So every month, say this program runs, and the program calls calculate interest amount for the accounts. So that would mean we would actually we'll set the self dot balance to be self dot balance plus self dot balance times self dot interest rate divided by 100. So essentially we're adding the balance and the interest to the balance itself. So I can do this in 2 steps. I can have a local variable called interest is equal to this, and then I can add interest here, and then I can return so I can do it this way. So I can have a instance method where self is passed, and there are no say this is monthly, so I have to probably divide this by 12, and okay, so I'm going to do it that way. So I'm going to multiply the balance and the interest rate and divide by 100. That will be the interest rate for the year, and then divided by 12 so that I get the interest rate for the month. And then I'm going to add it to the balance, and then I'm going to return the balance out. So this is something I believe I can do. So this is what it's going to do is, now the savings account is going to have all the methods that account had, and in addition it's going to have another calc amount. So to do that, let me instantiate a savings account again. Now if I want to say I want to see the dictionary for this, and then my no intention is that I want to see all the methods that account had, plus these additional. Okay, you know what, I have to use the class level to actually do it. So I want to see the savings, the class level, what the dictionary is, and I want to compare it with what the account level dictionary is. And I expect to see that the savings account has this in addition. So in addition to using all the account level things, I should also be able to calculate interest amount. So here, if I see, it has the calculation interest amount. That's a new function that's been defined. But the account, if you see, it has all these things. It has like update count, get account open, get balance, everything. So here now, if I want to call ac1.save dot, if you see that I'm able to call the get account open rules. I can, that is a static method. I'm able to call deposit money. I'm able to call get balance. I'm able to call withdraw money. I'm able to call update count, which is actually a class method, and I'm able to call calculate interest amount, which is particular to. So I get a new balance of 20,033 for this month. And now if I want to call ac1 underscore save, I can call get id, which is an existing like account level. It's at the account level. The dictionary is at account level. It's not at the savings level, but still I'm able to call that. So that's those are concepts based on the inheritance itself. Okay, that kind of covered a lot for today. This is the basics of classes and objects extended. I'm going to stop here. Thank you so much.